Hi everybody, and welcome to this talk. My name is Sebastian Deleuze. As you can hear, I'm French. I work at Pivotal on Spring Framework, so mainly on mostly on Spring MVC, cores, JSON, WebSocket support, and the integration with client-side technologies. Today, I will quickly introduce what isomorphic means. We will talk about Nashorn and the script-based templating support there is in Spring Framework since 4.2 release. Using Handlebars as an example. Next, I will introduce React and show you how to build an isomorphic application using it and Spring. Of course, there will be a demo, and we will finish this presentation by talking about what is coming next. So let's talk about what isomorphic means, since it's a kind of buzzword. Isomorphic means that you run the same code on the client and the server. In fact, there is various use cases for isomorphic, like templating, internationalization, application logic, routing, model validation. But since we are talking about building a server application based on Java, all these use cases that may be relevant with a Node.js application, when you can basically share everything between the client and the server, does not necessarily make sense in our case. So in this talk, I will focus on templating and user interface. So why should you build an isomorphic application? Well, for performance, Twitter, I don't know if you remember, but a few years ago, Twitter moved from a website where the data was loaded thanks to Ajax request to a website where the data are initially rendered on server side and only the updates, only the new tweets are retrieved thanks to Ajax request. And by doing this change, they noticed a 5 times improvement on the user perceived performance. That's huge, and that's even more when you think about mobile, when you have high latency, less bandwidth, and less CPU. So the first argument for isomorphic application is not necessarily accessibility, but mainly performance. You have to send less requests. You just send the page, it is displayed, and after that, you are sending all the JavaScript files to make that dynamic. It's also interesting to improve the maintainability of your website by sharing more code between the server and the clients, and by having a single technology to learn. Usually, currently, you use a templating technology on server side, for example, Thymeleaf, and you use another technology on the client side. By building an isomorphic application, you have a single technology to learn. And last but not least, it makes your website more crawlable, more accessible. So in terms of search engine will be able to index your website more easily. If your website is more content-oriented, you will provide the content without all the JavaScript thing. And it allows you to build a website with rich internet application and staying accessible. The principle is the following. The web page content and the UI are initially rendered on server side, including your JavaScript-based components. And when the web page is received on the client, the JavaScript components are usually re-rendered to make them react to the user actions. The relevancy of this kind of mechanism depends on the type of your website. The more your application content-centric is, like e-commerce or content management system, the more relevant it is. If you are just building a back office with a very rich rich UI, that's not necessarily makes sense. But if you are building a content management system or e-commerce websites where it's important to provide the content fast to the user, to make that content easily accessible, indexable, while you still want to provide some latest JavaScript-based UI, it's an interesting solution. I think GitHub is a good example of a website that's perfectly suitable for such approach. It's mainly content-oriented. GitHub is here to show you the commits, the code, the issues. but at the same time, it needs to provide you some nice JavaScript-based UI. For example, for the issue tracker, you have some kind of very dynamic UI. So I think that's a nice example of a website that is suitable for this kind of approach. Before talking about building an isomorphic application, let me introduce the new script-based templating support we have in Spring. We have developed this new feature after a very long, broad, and interesting discussion in the SPR 12/266 Spring JRuby issue. This issue was about how Spring Framework could help with working together JavaScript libraries. The outcome of this discussion was to add support for JavaScript templating in Spring, but in fact, what we implemented as a broader scope, it supports any template engine that runs on top of GSR 223 compatible script engine like JRuby, Jython, or Nashorn. Nashorn is a script engine bundled with JavaScript engine bundled with Java 8. So with the script templating support, you can really use any Python and Ruby-based templating system. Even perhaps, I have not tried, but perhaps ASCII-Doc support, you can try. But in this talk, I will focus on the JavaScript part, but feel free to test that with your favorite scripting technology. So let's talk a little bit about Nashorn. So Nashorn is bundled with the Java Runtime Environment 8 or superior. It continues to evolve fast, so please always use the latest build. This is really important. So Java 8 update 60 is a minimum requirement. Never use older builds, so this is the last one, in fact. Never use older builds because your favorite templating technology may not work properly on it. And even if it seems to work, there is some issues that may prevent to run properly under high load. So really, the Java 8 update 60 is the minimum requirement for that. When using React, there is a performance regression in the latest build. So for production, you will have to wait the Java 8 update 66 that will be released next month to have a good level of performance with React. So you see that's changing. So here is an example about how to use Nashorn to run some simple JavaScript code. So we first instantiate a new script engine instance specifying the Nashorn engine name. It's here that you could specify a Jython or JRuby. We assume the script engine implements the invocable interface, since Nashorn, Jython, and JRuby does. Then we invoke the JavaScript function hello with Brian as a name argument, and we retrieve the result as a string. That's basically what we do in the Spring script templating support with a lot more refinement, but basically that's the principle. We call a render function that is executed in the Nashorn script engine, and we retrieve the string, and we send that string to the client. We are going to see different technologies. So I have tried to put some small icons to identify what technology, what language we use for the code. The script-based templating is available in Spring Framework 4.2 and in the upcoming 4.2.2. I think the release is next month, or at the end of this month. There will be some script templating related bug fixes and improvements, so that will the one to use. And Spring 4.2.2 will be the version Spring Boot 1.3GA will be based on. So basically, with Spring Boot 1.3GA will be natively compatible with all this script-based templating we are going to see today. Using Nashorn, I have been able to test successfully the following template engines: Handlebars, Underscore, Mustache, Embedded.js, and React. Feel free to test your favorite one. Nashorn has a pretty good compatibility, but sometimes there is some issue. So feel free to test and to send us your feedback. As I said previously, always use the latest Java build. For example, if you don't use Java 8 update 60, _js does not work. _js is a library with a lot of utility functions, and there is a very small template engine built into it. Before talking about React, we are now going to explain how to use handlebars with Spring MVC, because handlebars is a classical templating system, quite close of the templating system you should already know, like Thymeleaf, Velocity, FreeMarker. So that's a simple one, and after that, we will switch to React, which is more than just a simple template technology. So handlebars allow you to define logicless templates. By logicless, I mean you don't put directly JavaScript code in your template, but you use the handlebars templating system syntax. It provides everything to expand values, iterating on collection, displaying conditionally some data. It's also easily extensible thanks to helpers written in raw JavaScript. So that's pretty interesting because the community has built a pretty large amount of handlebars helpers that you could reuse. And you could also add your own helpers easily by just writing a few lines of JavaScript. So in terms of extensibility, that's pretty nice. So here is a simple example of an handlebar template that we are going to render with Spring MVC. It expands the title value and iterates over the comment list to display each comment, author, and content. This is the Spring MVC controller that we are going to use. As you can see, this has nothing specific to the script templating technology. This is a regular Spring MVC controller like you have in Thymeleaf or Velocity or FreeMarker support. We have a home under method with a model parameter when we add the title and the comment attributes, and we return the home view name to specify what template to render. But using latest Java 8 and Spring MVC for the two features, we can do better than that. Be aware that the improvements I am going to show you are not specific to the script template support, but could be applied to Thymeleaf, Velocity, or FreeMarker. So the first thing I want to show you, I don't know if you are aware about that, but thanks to some improvements there is in the Java 8 update 60 version, it now allows to retrieve the lambda parameter's name. And guys have built a lambda type references project. I will send the link with the slide. That when you use the dash parameters Java compiler flag, that allows you to declare a Java map with this kind of syntax that is quite close. It's a hash literal, quite close to what you can write to declare a JSON object in JavaScript. So that's a nice syntax. Very short, that allows you to declare a map. The hash method is provided by the lambda type references project, and the rest is just Java 8 syntax with the lambda. So that's a pretty nice way to declare a map. The view name is guessed from the request URL thanks to the request to view name translator. That's a quite old Spring MVC feature. It's here for a very long time. But we can do even better. Spring Framework for the 2 introduces support for annotation aliases thanks to the new @alias4 annotation. Spring Compose is a project created by Sam Brannan in order to provide some kind of predefined annotation aliases based on this feature. For example, in this code example, we are using @get. You can use @post, and there is other annotation shortcut. This is just a shortcut for the @request mapping method equal request method equal get, etc. So that's just aliases, but that allows you to write some shorter code. Spring Compose provides you the most interesting ones, and you can also define your own annotation aliases with this new Spring for the 2 features. So when you are writing a lot of Spring MVC controllers, that saves a lot of characters. So back to the main topic. Nashorn is bundled with Java 8, so no specific dependency to add in order to use it, but you have to specify the dependency for the template technology you are going to use. For that, we are going to use WebJars, which are client-side web libraries packaged into jar files. You can also just add the JavaScript file in your SRC main resources directory. But for this project, we are going to use the WebJars. So you just have to declare a regular Maven dependency in your pom.xml, and that will make handlebars.js available in the class path. The next step, like with any other Spring MVC view technology, you need to register a view resolver. So here we specify the prefix and the suffix for the template. So we're creating a new script template view resolver, and we specify the /static/templates prefix and the .html suffix in order to, when we return the home view name, it will try to find in the class path the /static/template/home.html. So nothing specific to this technology except that you have to create a script template view resolver instance. That one is more interesting. So you also need to, like other view technology, to create a configurer bin. So this is a script template configurer bin. This is a generic template configurer that where you should specify several parameters. The first parameter is the engine to use. So in that case, you were specifying Nashorn. You also need to specify the script to load. So in that case, I specify polyfill.js, handlebars.js, and render.js. These scripts are loaded in the global JavaScript scope when you start your application. And also pay attention to the sharedEngine property. We are going to detail this one in the next slide. So this is a pretty important topic with Nashorn. Concurrency is not a topic you can ignore. In your web browser, so JavaScript is expected to work in the web browser originally. There can be simultaneous execution of your JavaScript code. Even web workers, which are some kind of lightweight thread for JavaScript, are using a shared nothing approach with message passing. So basically, you have no concurrency issue with JavaScript in the browser. On server side, Nashorn is by design not thread safe. That means that if your JavaScript code use some global stateful variable with a single Nashorn instance and you use it in multiple threads, that will explode. That will not work. So since your Spring MVC is typically multi-thread, we introduced the sharedEngine Boolean property. So by default, the script templates support use a single Nashorn instance because some JavaScript library do not use any kind of shared variable. So for example, with Mustache, you can use a single Nashorn instance and that will work perfectly. But for other script engine like Handlebars or React, so that these are more complex template engine, you need to set sharedEngine to false. And when you set it to false, we will use one script engine per thread. So basically, we are using a thread local of script engine, and that allows to avoid any concurrency issue. Be aware that since you are using a script engine per thread, you may be careful about the memory consumption because you are going to load as many Nashorn instance, as many you have threads. So you may create multiple Nashorn instances that will all load the JavaScript files you are going to use. So be careful on the memory consumption, but it really depends. Yeah. Excuse me. I mean, with Node.js, you will have to build some kind of pool of Node.js. So I guess that will be. I think that will be the same, but I'm not sure. The first script we load is polyfill.js. So it defines objects or functions unavailable natively on the server side, because some objects exist natively on the browser, but not on the server side. So in order to make it possible to run handlebars, we just have to create the window object, which is typically a browser thing. But we just have to create an empty window object, and that's fine. That's enough to get handlebars running properly. This is an important thing. This is the render.js. So this is a JavaScript file that will contain the render function corresponding to the function name you have specified in the configurer. So you have to provide this file. There is no built-in implementation. We are not opinionated about the script part. So in Spring 4.2, we provide all the infrastructure to use that, but you have to provide the scripting part. Perhaps we will see some side project providing some built-in script files for React, for handlebars later. Feel free to contribute that in the community, but currently you have to provide that, so you can use the handlebars and React example. I will show you the address of the GitHub repository, and perhaps there will be some project that will provide that by default. So the render function can take 2 or 3 parameters. The first parameter is the template content. So basically, that's a string that will contain the template content. The second one is the model, where you have added the attributes that will be used to render the template. And the third one is optional. This is the URL. So basically, you know here that you are using the home view name. That's a very interesting feature of the script templating support, because this is a nice extension point where you can do what you want. So that's also dangerous, but that's quite powerful. You can do any customization you want without any change in Spring framework. So feel free to use that. Debugging in Nashorn, I think it could be improved. That's not always easy, but I guess with some stub you can debug it in any JavaScript engine. So maybe in Chrome you can try it. But when you run that into Nashorn, I think they try to provide some more meaningful stack trace. I have seen something like that in the mailing list, but currently, yeah, when you have an exception that throw, that's not so easy to debug. Here we can see the handlebars implementation for the render function I have created in this sample project. So this is an example of customization. Handlebars compiles template to JavaScript function. So basically, you have the handlebars template string that I have shown at the beginning. Handlebars will compile this string to a JavaScript function that take as input the model, the context, and as the output, it creates some string, which is the render page. So if you implement that naively, you will just, each time you render the page, compile the template and use the resulting function to create the output. In this sample, very short implementation, I'm using a template cache. So it's basically a map where you are putting the view name, the view URL as a key, and the function, the template function as a value. So if we have nothing in the cache, we compile the template and we store it. And after that, we use this function, we invoke it with the view model argument, and we return that because that returns the string that will be sent to the client. You can notice that there is a toJSON Object function. More about that in this slide. The object passed from Java to JavaScript are passed directly as they are. So the model object that we have is still a Java map. So even if Nashorn provides some language extension that allow to iterate around a Java map with a for loop like there is in this sample, this is not really, the template engine usually wants a real JSON object with JSON arrays, a real native JSON object. So with this sample, this sample function, I'm converting a Java map to a real JSON object. And if I found something that is an instance of iterable, like a list, I convert that into a real JSON array. That allows us to have a real JSON object to pass to the template technology. But is it fast? I mean, we are talking about running some JavaScript code every time we want to render a page. Sounds a little bit weird. Is it suitable for the level of performance we expect in production? Yeah? Because in that case, we are creating a JSON object that will be passed to some JavaScript executed on the server. So we can't just pass a JSON object created by Jackson. Jackson is useful to serialize a Java object to a string that represents a JSON object. But here, we really need a JSON object instance that will be interpreted by Nashorn to render we really need the instance, not a string that represents a JSON object, but a real JSON object. Yeah. You will have a string that represents a JSON object, but the engine will can't use that. No, that's not the same thing. A string that represents a JSON object, and this is a real instance of a JSON object. That's not a string that represents it. It will return a JSON node instance. Yeah, and JSON node can be understood by Nashorn and the script engine. I will try to explain that better after the talk. So is it fast? With a simple handlebars template expanding the values and iterating other collection on my laptop, I have been able to reach 500 pages per second without the catch support and 6,000 pages per second with it. So even if this feature will be, these numbers will be less impressive with real-life example, I think we have a pretty good level of performance. It is bench, it is stable, yeah, I think that's pretty interesting. And that's just a demo application. I think we could get more optimization. And Nashorn continue to improve its level of performance, so I think that's reasonable to use that in production. So should we consider handlebars and Spring script template support as a real alternative to Thymeleaf, Velocity, FreeMarker, or Groovy markup template? Well, it's nice to use, easy to customize. We have a good level of functionalities with all the handlebars extension, all the handlebars helpers, and it's quite fast. But on the other side, this is quite a young stack. As I said, Nashorn continue to evolve a lot. So, and the Spring script template support is quite young also. And that may be an issue or not, but you really need the latest Java 8 runtime. So depending on your ops team, I guess some ops team will not be very happy to have to install the latest and greatest Java 8 runtime. So that may be an issue. Something that is missing, and I hope that will be contributed by the community. Feel free to contribute that. Handlebars allows the usage of nested templates, but the nested templates have to be loaded from somewhere. And you have a solution to load all the nested templates in your JavaScript instance, but that's not very, very nice. So it should be possible to develop a simple handlebars extension, a simple handlebars helper that load nested template from the class path. I have put a little code example when you can see that it is easy to call Java code from Nashorn. So for the real code, you will have to use Spring Resource Loader, but that's just an example. So I think with a few lines of code, we could build a small extension that could allow to use nested templates with handlebars. And with that, and with the handlebars layout extension, we reach quite the same level of functionality than Thymeleaf, than Velocity or FreeMarker. You can easily experiment and hopefully contribute by forking the Spring Boot web handlebars repository I have created for you with the code sample we have seen until now. So we are finally going to talk about React. So what is React? React is a JavaScript library for building component-oriented user interfaces. This is not a full-stack framework. This is mainly focused on components. It uses a virtual DOM mechanism useful to update the web page efficiently. And it is designed to allow server-side rendering. So in order to efficiently update the web pages, React observes which component states have changed in order to perform batch updates of the dirty components and their related DOM nodes. And that's pretty interesting because updating the DOM is slow. So basically, React has an internal model for the changes, and it just performs the update of the changing part. It's a little bit like a diff, in fact, when you are using Git. It will compute a diff based on the previous version of the page and only update the relevant DOM nodes. So that allows a pretty powerful thing. You can re-render all the web page, and it will just change the relevant nodes. It's fast. It avoids your web page to flicker when you re-render it. And if you have a user that has selected some text, for example, it stays selected. So you don't kill all the DOM and create a new DOM node. You are just updating the relevant parts. That's one of the main innovations behind React. I am now going to show you some React code, but before, be aware that React components are usually written using JavaScript and JSX. Some people like JSX, some people don't. You will quickly see why. So here is a JSX code sample. So this is a sample React component designed to display a command composed by an author name and a content text. As you can see, React is throwing out the notion of templates thanks to JSX, which allow to inline XML or HTML code directly into the JavaScript code. So that's why some people don't like it. I can understand. During the compilation or at runtime, you have the choice. JSX code is transformed by React to pure JavaScript code. And you can see that's not a huge transformation, I guess. At the top, you have some HTML and React code elements, and at the bottom, you have some JavaScript code, but you can see easily the matching. So that's a very thin transformation, very simple, very fast. And this JSX thing is mainly syntactic sugar. It allows you to write that in a more maintainable way. So the fact that we have to inline that into your JavaScript code is perhaps not perfectly clean, but when you are writing complex components, it's more maintainable when you write the elements than the JavaScript code like that. So it's possible to use to write React components without JSX, but as the most interesting man in the world said, I think you should use it. If you use React, I think you should use JSX to write your components. For simple components, it's doable without it. For real-life components, complex one, I don't think that's maintainable. But that's possible, you can do that. You can have a look to this other component example. So this is a comment-list component that iterates other comment state property to display each comment. You can see these comment node functions used in the JSX code that instantiate for each comment a comment component properly parameterized. So this mix of a markup and JavaScript code is a little bit strange at the beginning, but it works pretty well. And you have everything, you have all your components into a single file. So we are finally going to see how to build an isomorphic application with Spring and React, thanks to a new sample project. I will give you the link to the GitHub repository at the end. So for this project, I have chosen Gradle. Yeah. Oh, at the beginning, it was not really clear. Isomorphic application is building. So in this context, it's creating some components, some UI components that will be rendered on server side and on client side. The same components will render on both sides, and we are going to show how. So for this project, I have chosen Gradle. I use a React Gradle plugin to transform JS6 to JavaScript at compile time, and React dependency comes from WebJars. You can use Maven as well, but I think that if your project have both Java and JavaScript code, Gradle is more suitable, it's more flexible, less Java-centric, and you can easily customize your asset pipeline with Gradle. So I think that's a better idea, but you can use Maven if you want. That's possible. So we are going to see how to develop a simple isomorphic application to allow to post comments and broadcast them to all the connected clients thanks to the server-sent events. So you can see at the top that we have a command form component that will be used to send new commands. You have the comment list and the comment components that we have detailed previously at the bottom. And all of this is in an embedded.js template. I am going to explain why. So the Spring MVC controller retrieves the commands from a repository, like you should expect from a regular Spring MVC application. You add the commands in the model attributes, and we return the view name, like we have seen previously with handlebars. Nothing new on that part. So this is a special point with React that may not apply with other technology, but React is mainly not a real template engine. It's mainly about components, and it's not really suitable to render, to bootstrap the initial page. So that's why I use embedded.js layout. That's more a classical layout, a classical template technology. And you can see that that's pretty much an index.html file with some dynamic parts where I can call directly JavaScript code. So I am calling the react.render.toString function to create the component on server side. So this index.ejs file is only rendered on server side. That's only to bootstrap, to render the view. And when the template is rendered on server side, React, in fact, embedded.js and React generate this kind of static HTML. So you can see that that part is rendered on server side. That's HTML with just additional attributes like data React ID and data React checksum. That's data attributes that React will use to properly update your components and check the state, if the state of your component has changed. But that's basically some HTML with some data attributes. When the page is received on the client side, there will be a demo after that to really show how it works. When the page is received on the client side, the client.js re-renders the React components in order to add the JavaScript DOM listeners. The command form component can be rendered directly with, while the comment list components, we need to retrieve the commands thanks to an AJAX request sent with jQuery, and then we render it. For that, I have done that manually. For a more production-grade application, we could find some more nice way to do that. But basically, that's the thing. You have received your web page rendered fully on the server, and you re-render the React components in order to attach the DOM listener that will react to the user action on the UI. And what is interesting here is that React will generate exactly the same HTML on server side than on client side and on server side. And thanks to its DOM diffing capabilities, it will basically update nothing. If you see the DOM before and after the client side rendering, it does not change. The only thing that React will do, it's attaching the DOM listeners that will react to the user actions. We continue to see the file needed for this implementation. So we need a polyfill.js in order to declare the global and console objects, since they only exist on the browser and are needed by React. The render function just invokes embedded.js render function that in turn will render the React components. So this is the render function executed on server side. There is several things that could be improved in this implementation. For example, there is some script duplication. Currently, we have to specify all the script to load on both index templates interpreted in the client side and in the application Java with our script template configurer. This is still some homeworks to do. It does not exist yet, but I think it should be possible to develop a JavaScript module loader extension, for example, a require.js extension that load resources, that load, in fact, JavaScript module, JavaScript files from the class path instead of sending an AJAX request like it is done with require.js when you lazily load the dependency. I think that's a 10 lines extension and that will work, so something to try, to just use a module loader to specify one time the dependency to use, and that will be used on client side and server side. Last code samples, and after that we will show a demo. In this application, we use the new Spring 4.2 server-sent event support to send the new commands to the connected clients thanks to a list of connected SSE emitters. So you can see at the bottom the subscribe updates. It's a server-sent event endpoint where the application connects to the is loaded on the browser. It subscribes to the /SSE/ server-sent events endpoints. It will create an SSE emitter that will be added to a list of SSE emitters. And when you create a new comment, you will basically iterate over all the SSE emitters and send them the new comment we have created in order to push this information. On client side, we use the React component-dit-mount lifecycle function to subscribe to the server-sent event messages and update the state of the comment-list component. Yeah? Now, it's for SSE, unlike the WebSocket Storm support, where you can send a message, broadcast a message to all the users in one operation. With the SSE support, each SSE emitter is one user. So you basically have to iterate over other SSE emitters to send that. I could have been used the message mapping support to do that in one operation. That was just to demo the SSE support. So you have to iterate over all the SSE emitters to send that to each client. So let's go for the demo. Oh. So let me share my screen. Okay. So this is the application I have described. Just a quick review of the file. So this is a regular Spring Boot application with a main. In this init methods, we just create some sample data in our in-memory repository. We have the React view resolver and the React configurer we have detailed previously. We have the command pojo, we have the command controller, command repository. For the JSX part, so here we have all the JSX components, so a mix of JavaScript and HTML or React components. You can see that. And I have an output directory. This directory is created by the Gradle JSX compiler plugin. And in that one, you have the pure JavaScript functions that are transformed by this Gradle plugin. So this is automatically generated each time you make a Gradle build, basically. And the polyfill.js and the render.js, etc. And in the application properties, that's a new feature of Spring Boot for 1.3. We increase the request timeout that's usually needed when you use server-sent events. So I run the application. Okay. Okay, so that's my application. What we can see if we are going to the Chrome tools. So let's reload the page. It's quite small, but it's regular HTML. This code is generated on server side, and that's regular HTML. If you can see that here I have JavaScript enabled, so my application is working. If I disable JavaScript, so this is a little Chrome extension that disables completely JavaScript. Okay, I reload the web page. So I still see the content, but obviously my dynamic functionalities does not work. But the content is here, and that's some kind of progressive enhancement. If you don't have JavaScript, you still have the content, but you don't have the dynamic interaction with all the UI components. That's a nice trade-off when you can't have that. I'm enabling it. I am doing a small demo of the application, nothing really complex, but okay. So I'm sending a message. And thanks to the SSE, it is sent on the both instances. Nothing really great, but so yeah, the most important part is that when you disable JavaScript, you still have your content. And so when you are building some e-commerce or content management system solution, I think that's pretty important to have the content in the markup retrieved. So that could be interpreted by some search engine indexer that could be used to retrieve the metadata, and only the dynamic part is optional. Okay, I'm going to continue the presentation now. Okay. So React is interesting, but it has also some drawbacks. It's just about components, not the whole application. It requires the use of higher level architecture pattern like Flux or higher level frameworks to do a whole application. Nashorn is still young, so what are the next steps? The first important thing I would like to talk about is EcmaScript 6. So EcmaScript 6 is basically the upcoming JavaScript version with much needed functionalities like modules, classes, and more JavaScript libraries are written in EcmaScript 6. And when you are writing JavaScript code, you are likely to want a better JavaScript, especially since we are Java and Groovy developers. So I guess everybody wants some nice functionalities like types, this kind of thing. Not types, it's not it in EcmaScript 6, but at least the classes, for example, this kind of thing. So Nashorn version bundle with Java 8 already supports a few EcmaScript 6 features. So to try them, you have to use -- language equals ES6 flag. That's not official yet, I think, but Nashorn bundle with Java 9 is likely to have full support to EcmaScript 6. I have seen this tweet retweeted by the Nashorn project lead, so I assume this guy don't say some bullshit. And as noticed by Benjamin Winterberg, you can already use Babel.js to transpile your EcmaScript 6 code to EcmaScript 5 that will be natively understood by Nashorn. So by using a transpiler, you can do that today. But there is even better than EcmaScript 6. There is also TypeScript. So TypeScript is basically an EcmaScript 6 superset with some additional features like types. Yeah, types in JavaScript. And decorators that are like our annotations. For your information, Angular 2 is written in TypeScript 1.5, so that's a pretty nice thing. There is an active discussion with some proof of concept about getting, so TypeScript is a transpiler, so there is some proof of concept of getting TypeScript compiler running on top of Nashorn, but you can already write some TypeScript code and run it on Nashorn using the TypeScript Gradle plugin. Be aware that it will require Node.js to run, but that's just for the compilation part. But there is not only React. Ember.js, for example, with AngularJS is one of the best JavaScript framework to build enterprise-grade front-end application. Ember.js 1 is using the Handlebars template engine we have seen at the beginning. But Ember.js 2 is based on HTML bars, which is basically a template engine that uses handlebar-style templates. But instead of rendering to a string, it generates some DOM transformation operation like React. So basically, you have some simple templates like we have seen at the beginning, but with the React performances. And it is still possible to run it on server because they are using some DOM abstraction. So basically, when you run that on the server, you don't use the browser DOM, you use a server-side DOM implementation that still allows to render the template on server-side. So that's pretty interesting. Also interesting, Angular 2 application, isomorphic application are also coming. That's not on the top priority of the Angular 2 team, clearly, but there is already some community-driven effort to get that running. And if you have a look to some sample Angular 2 components, it seems to very, very appealing to me as a Java developer because it's using classes, it's using annotations, it's using all the improvements there is in TypeScript 1.5 and EcmaScript 6. So if I am able to build an isomorphic application with Angular 2, I think that's a pretty interesting option. I have not detailed that, but if you are building a real production-grade application, isomorphic application, at some point you will need to build a bridge between server-side and client-side routing because basically you can reach directly your web page and it will be rendered by the server-side, but you can also, when you are using your web page, you don't want to reload the page each time. So there may be some need to share some information about the routing. I have not worked on that topic, but I guess that will be a need for this kind of application. So feel free to experiment. Any contributions welcome. As I have explained, it's a very young topic, very promising, but there is a lot to do. There is a lot to experiment with the latest JavaScript improvements, with the latest frameworks. So feel free to send us some feedback about that. So my conclusion is that JavaScript evolves a lot with EcmaScript 6 and TypeScript. It's getting all we could need to build enterprise-grade applications, module, classes, annotation. JavaScript frameworks like React, Ember.js 2, Angular 2 are leveraging this improvement. They are becoming more mature, more stable. The issue currently with the JavaScript frameworks, they evolve too quickly. Every month there is a new framework. Every 2 months they are changing, refactoring everything. Everything is broken. And in Spring Framework, we try to not to break your application. And when you saw what occurred on the client side, I perfectly understand that it's scary. So what we can say is that the guys, perhaps not on React, but on Ember.js 2 and Angular 2, they are taking their time to build something clean. So we could expect that they will not trash that in 6 months. And JavaScript, the JavaScript improvements will be are going to be more widely used. So we could expect more stability also on the client-side part. Isomorphic application provide a nice balance between the, I don't say all server-side rendering because it is still interesting. It is not all, but it's a nice balance between server-side rendering and the JavaScript-based rich internet application style that was some kind of separated worlds. And the isomorphic application make a nice balance between these two kind of application. Maybe, develop your front-end skills and don't be afraid. The new JavaScript, especially the TypeScript 1.5 version, it's just a pleasure to use for Java and Groovy developers. So maybe begin by that, since now we have types, we have annotations, we have this kind of thing. Try by yourself. There is a lot of buzz around all these frameworks, and you may be convinced that Angular is the only solution, or React is the last to use. But I have seen some people trying Ember.js, for example, and they found that it fit perfectly to their needs. So try that by yourself. Also go see the Matt Rabel talk tomorrow. He will compare React, Ember.js, and Angular. So that's pretty interesting to see. And my last word will be about the choice of the client-side technology and the software design you have on the front is a major differentiator for your product or your project. So usually we are very serious about the technology choice for the server. So you may, for example, choose Spring Boot for your next application. And for the front, perhaps I will use some old jQuery-based technology or some other thing, and that's sometimes not as important as it should be. So I think, for example, for e-commerce or content management system, that's a key differentiator. Current solution, not all, but current solution have usually an outdated front-end stack. So maybe this is a key differentiator where you can build something nice using all this new stuff. The source code of the Spring React Isomorphic and Spring Boot sample web handlebars, quite long name, application are available on GitHub. Feel free to contribute some, feel free to fork it to contribute some support for your favorite template engine. You can follow me on Twitter. I will tweet in a few minutes where you can download the slides with all the links. Thanks for being there, and I'm available to answer to your questions. Yeah?
I was just curious, the first thing that actually came to mind to me was bypassing ad blockers while restricting what they can do to make browsing ugly.
Mm-hmm.
I think that's sort of a use case.
Maybe I didn't add this ID, but yeah, basically, yeah, you can generate that on server side and avoid this kind of blocking. Yeah.
Have you done any graphics rendering? So one thing we've been looking at is only one, 2, 3. Have you done that at all?
No, not yet. I don't know if it runs under Nashorn. That's, yeah.
Which one did you say?
Does isomorphic application works with some graphic libraries like diffing.js, for example? I'm not sure. It needs some canvas stuff, so I have not tried, but that's a very interesting question. Need to try that. Maybe with some kind of advanced polyfill. I have shown some handwritten polyfill, but I guess maybe for some missing parts, missing capabilities on the server side, some people has written some kind of more clever polyfill that's allowed to fill the gap on the server side, but need to check that.
But since the page rendering is on the server side, is there any benchmarking around network usage?
For the network usage, that's pretty much the same that regular view technology. The main thing I have to say about that is that, in fact, some data are transferred to time. So I have shown that the rendering is quite fast, at least with handlebars. So you just render the web page like with any other template technology, but when you re-render the components on the client side, I don't know if you remember, but you have to send an AJAX request to retrieve the comment list to get that into JSON, release the JSON array of the comment list to render that on client side. Donc, there is a higher network usage because basically you are transferring the first time the comment list as a markup, and the second time you have to retrieve the JSON array thanks to your REST endpoint to render it. So initially there is more usage at this point, but I think what you gain in terms of latency, you directly display the web page without having to wait. I think you have all experienced that with very dynamic JavaScript UI, you have to wait every JavaScript file is loaded. Gmail, for example, you have to wait. Everything is loaded. So with that, you really have directly something displayed, but perhaps there is some higher network usage because you have to retrieve the JSON object to render that again on the server side, on the client side. Maybe with some improvements, we may avoid that step and just ask to React to, for example, attach the DOM listener without having to retrieve all this data. This is something to.
So when it comes to loading images, right? So are there any issues? Let's say I'm trying to combine all the images into one file and then strip it off on the front end to display the icons however I want.
You can do that, but I don't know if you have seen the Brian Clausel talk about HTTP2. In fact, what he says is that currently we try to minify the files, to use some image map to make the number of requests much lower. With HTTP2, we are basically opening a single connection, and the fact that we have one file or many, it does not really. It's not important. So I guess with HTTP2 there will no such issue. And
so with this I don't have to combine the images into one and I can go back to however many I want to load, right? Or is what you're saying?
Yeah, you don't have to do that. And since your web page is directly rendered, I think that's you don't really need that. Yeah. Could you speak louder, excuse me? As I said, I think the only thing that is missing for that, so is there any support for modularization? You just have to build, for example, a small extension to require.js to be able to retrieve the JavaScript files from the class path. But I think that's a 10-line extension, the same for the handlebars template, for the nested templates. I think with that, I have not the time to contribute that myself, but that's pretty easy to write. You really use your JavaScript module loader to load the same way on client side and server side. But when you will be on client side, the module loader will send some AJAX request to get the JavaScript file from the network, and when you will be on server side, it will retrieve the JavaScript file directly on the class path, and that will be the same code on your. But that's not available. Just a little extension that is missing. Feel free to contribute. Yeah. You can exactly. You can retrieve your JavaScript files from the class path from your web jars, or you put them in the SRC main resources directory, and you get it from that. The thing that I'm not there may be some tuning to do because the path of the file should be the same on the network and on the class path. So there is perhaps a prefix to manage, but except that, that will work the same. Okay, thanks.